Hi, I welcome you all to this new video. So the question we are seeing today is linearizing a generic tree in an efficient manner. So like in the previous approach, we linearized the tree, and if you haven't watched that video, I highly recommend you do that because it built the foundation of this question, right? It built the foundation, and you won't be able to understand it quite clear because, yeah, if your basics are not clear, then you won't be able to understand it. But nevertheless, in this video, we are actually doing it in an efficient manner. The previous one, the previous approach was of n square, and we are converting it to big O of n, right? Now, how do we actually propose to do that? So in the previous question, we had the faith that my children know how to linearize themselves. Then I'll cut out one children of mine and will place the tail of the other children in the head of the child removed, right? So that was the approach. And if you don't really get it, I again recommend you to watch the video. So in this efficient way, I change my faith that my child knows how to linearize itself, and it will also return me the tail of the linearized series, right? It will also return me the tail of it, right? Now let's see. If I had a tree, suppose 10, 20, 30, 40, 50, 60, 70, 80, right? If I had this tree, so I have my faith that my child will linearize itself. So this function will actually make itself to be 40, 70, and 80. It will linearize itself. Then I'll cut this function off. Just a second. I'll cut this child off. We'll have a faith that my second child will linearize itself. That is, it will become 60. Then I'll put the tail of the second child on the head of the removed child, right? And I'll continue this operation until the children array list, right? The size of the children array list of this root node becomes equal to 1. So I'll again have the faith, and I'll cut this node off here. I will put this the tail of the first child to the head of the second child, right? So let's try to code it once, and once we'll code it, you'll surely understand that. Firstly, I'll get the tail of the last child. So let's call it tail of last child, right? And we will linearize it. Node dot children dot get. How do we actually fetch the last one? Is node dot children dot size -1. Cool. So I'll be running a loop while node dot children dot size is greater than 1. I'll be doing this. Firstly, I'll obtain the last node. So node last is equals to node dot children dot get node dot children dot size -1. But instead of getting, let me just remove it from here, right? Because in the end, eventually I'll have to remove it. And as I have removed my last child, I'll be needing second last child, because on the on the tail of the second last child, I need to put the last child, right? I can get it like this. Node second last is equals to node dot children dot get node dot children dot size -1, not 2, right? Because the last child is removed, so the now last is actually, or eventually, my second last, right? So I have my last child, I have my second last child. Now let's linearize second last child and get the tail of it. So node tail of second last is equals to, linearize second last. And in the children of second last, that is tail of second last dot children dot add the last child, and eventually return the tail of last child, right? This should run though, but there is a base case we'll be needing. That what happens if the node has no children at all? Then this here node.children.size will result in 0, and 0 minus 1 will eventually give me minus 1. And getting the minus 1th node will eventually result in an error or exception, right? So I'll be putting a base case that if node.children.size is equal to 0, I'll be returning the node itself, because if it does not have any children, so it is the leaf node and it is the tail of the node, right? Tail of that series, basically. Let's try to run it this time. Okay, so there is a compilation error. Cannot find the sim. Yeah, so it should be children, not. Okay. Where's it should be children. Wait. Okay, so another compilation error. Non-static children cannot be referenced from a static concept. Children are removed, not children size minus 1. And it should not be a node, actually, it should be small n, right? Node is the name of the class, not the object of it. And one more compilation error. What is this? Of course, children. So these are just minor typing errors, not big ones, right? The logic is fairly correct, so it's getting accepted. Let's try to submit it now. So it's getting submitted, and errors are just part of being a programmer, right? So I hope you like the explanation, and if you did, kindly press that like button and subscribe to our channel. Thank you very much.